Welcome in LightWave 2020 update video. In this video I'll show you what is new in latest version of LightWave. In first chapter I'll show you new offset TR tools. Original offset tool is now divided into two separate specific tools. Also in chapter 2, round tool is divided into two new TR tools, and both these offsetting and rounding tools are now working very well and are completely updated for Mesh TR engine. In third chapter, I'll show you new NURBS refinement tools and new adaptive freezing tools, also updated for Mesh TR. In fourth chapter, I'll show you new Road TR tool. Road tool in previous version was removed from LightWave. Now it is back and it is way much better. In chapter 5 I'll show you new topology tool for inspecting topology in Mesh TR and quad patch quad commands. In final chapter I'll show you what you can expect in next versions of LightWave. I hope this video will cheer you up in this current gloomy situation. Offset tool in LightWave 2020 is completely updated from previous version, which is still available in legacy folder here, and it is updated to two new separate Mesh TR tools, offset curve and offset edge. The reason of this split is to get user more control about offset operation on different geometry types. New offset curve tool works only with NURBS curves and works only in orthogonal viewports. So first step, you need to set proper ortho viewport with this OpenGeo button or here with a ground viewport setting. And then you can apply offset the same way as previous version. You can use single side or double side offset, but new version has much more optional parameters. You can customize single and double side mode with additional parameters for connecting and or not connecting open ends. So you can enable this for both modes separately. You can disable removing base curve. So if it is removed, then after operation done, the original curve is removed, and you can enable a fixed tangent ends parameter, which I describe later. The precision of offset operation depends on how many control points you have per NURB segment. If you have a small amount of control points and the angle between these control points is too high, then you get bigger error. You have three ways how to control this. You can switch between precise end tangents and precise ISO offsets. So if you enable fixed end tangents, then end tangent of the offset curve will be precise with original curve, but ISO offsets there will be error. If you disable this, then the ISO offsets are precise, but the end tangent of offset curve is different from original. And the third way is to use new refine tool, and you can refine curve to maximum possible angle between control points, let's say to 15 degrees. And on this oversampled curve, when you use offset curve operation, you can see there is no difference between this option anymore, so the precision is much higher. In LightWave you can choose between so many control points and high precision, or smaller precision but very few control points. This is not possible in usual CAD application. They oversample offset curve by default and you don't have control about that. Additionally, you can use offset curve tool also on surface object. With Smart Selection, for example, you can select these surface, but offset will be just curves. So you can offset edges of polygons and NURBS surfaces and offset them into curves directly. Like this roof, you want to put gutter here, so holding Ctrl key, you can select this edge, and with Ctrl key the whole loop is selected, and use offset tool, so NURBS curve is created as offset from this loop selection. So this tool is very flexible, even on a surface object. The second version of offset tool is offset edge tool, and with this tool you can offset edges of polygons and NURBS surfaces. So you can select all of them, or you can select just some of them. With Smart Selection you can select the groups. For example, with Ctrl key you can select only these two, deselect, and then offset into particular site. So this is pretty much same offset tool as previous version, but the real change is on NURBS surfaces here. Here the offset edge works completely different than previous version. Previous version of offset tool, now offset legacy, was not actually doing offset operation correctly. It was just splitting NURBS surface into two pieces, and the offset on the beginning and end of the offset edge was just the average of the offset parameter. So for some irregular shapes, there was visible difference in offset on the beginning and end. So this was just a simple trick, and it was done by this way because this operation is very simple and very precise. If you split NURBS surface into two pieces, it is pretty standard operation, and there are no problems with this. But for real offset, it is much more complicated. So if you use new offset edge tool and offset this edge, you can see all offsets along ISO points are identical. So this is true offset now, and you still have benefits of the previous version. So the amount of control points is identical, and the precision is pretty nice. If you want to make this even with better precision, you can still oversample surface with refine tool. But for quick drawing, this is pretty much enough. Standard CAD applications are doing this, that once you do operation like this, the whole NURBS surface is no longer to be able to edit. You cannot modify control points. It is grouped into some surface, and you no longer have access to control points. And these edges are oversampled, of course. So LightWave is much more cleaner, and you still have the benefits of small amount of control points, and you get still two NURBS surfaces after operation, and you can still edit these control points like on a regular simple NURBS surface. Additional option in this new tool is a NURBS topology. You can now enable, disable NURBS topology. If it is disabled, then incident NURBS surfaces are not divided. If you enable it, then all incident NURBS surfaces are automatically divided to keep topology. If you don't do this NURBS topology, then after offset operation, the hidden hole is created here, because you cannot join two NURBS surfaces when one surfaces. So now you have, this is optional. Round tool is also divided into two new rounding tools: round corner a round edge. Previous version of round tool is here in legacy folder, and you can still use it, round legacy. You can use new round corner tool for rounding NURBS curves corners, so corner sections between connected segments. And same way, you can also round polygon and flat surface edges. So if you already have converted curves into polygons, you can still round corners now. So you can see this is much more flexible now. New round corner tool has same identical 3 basic modes. You can use fillet, chamfer and blend mode. Fillet creates arcs in corners, chamfer cut the corners with a line, and blend makes smooth blending between these connected lines or curves. And with blend mode we have additional blend scale parameters, so you can set how strong the blend operation will be. Another very useful new feature is the limits option. You can set limits to center or weighted, and this option defines how two neighbor blended or rounded corners will be overlapping one each to other. So in center limit, when you reach center point of the shared segment between those corners, you cannot pass this center point from one side or from second side. Here, center point. And if you set the limits to weighted, then the always stronger round corner will push to another corner. So this is weighted or center. Center is always frozen into the center point of this segment. Second version of rounding tool is the round edge tool. This tool is specifically for rounding surface edges. Surface can be polygons, flat NURB surfaces or NURB surfaces. And we have same 3 identical modes: fillet, chamfer, blend. And for current polygonal object, it is absolutely perfect. This tool now works 100% with polygons. All these special cases on these rounded corners are now working very nicely. There are no problems with polygonal objects. Works also 100% on object which is mixed with polygons, flat surfaces and NURB surfaces with no more than 2 incident surfaces per edge. So for these mixed surfaces or objects, it works 100%, same as polygonal version. Here on this object, a lot of cases was resolved, and now it works very well. And finally, we have cases when both sides of the edge are NURB surfaces. Previous version of round tool was almost useless. Now it works very well because there is a new design. We are rounding each isopoint, along each isopoint, and side edge is using offset edge routine. So we have minimal count of control points, and if we need to make even higher precision, we can still refine surface into more control points, and then when using round we have more these isopoints, more rounds, and even higher precision. So now this rounding of NURB surfaces works 100%, but simple NURB surfaces has some limits. You are not able to create any shape with simple NURB surfaces. Round tool is using a lot of tricks to keep topology clean, but even with a lot of improvements, you are not able to create any round on any custom NURBS object, especially if you need to have clean topology. NURBS surfaces will be updated to next revision when projected edges will be allowed to simple NURBS surfaces, so that standard design will be also in LightWave, but the original idea of LightWave toolset was to squeeze maximum from simple NURBS. Then, if there is no other way to use these polysurfaces and freeze the surface into complex surface when you lose control about control points. So with current design, sometimes it helps if you disable NURBS topology and you get the clean result. NURBS refining and freezing to polygons. Both these routines or operations are very essential in processing NURBS surfaces, and both of them are heavily updated in the latest version. Refinement in previous version was possible only manual way, so it was able to use refine edge with adding knots into curve manually and also remove them manually. So this was possible before. Now there is additional adaptive mode, and it works this way. When you enable adaptive mode in edge refinement, then it is using two parameters, a max angle and uniform ratio. I will lower uniform ratio to 0, and if you set maximum angle to very high angle, then it has no effect. So when you start lowering maximum angle, it always finds the angle between two control points which is higher than this max angle, and it automatically insert knot into curve. So with this parameter you are refining level of detail on curve, and knots are inserted first into more curvature parts of the curve. But mathematically might be this correct, but sometimes you need to make this insertion of knots more uniform, and for that is here uniform ratio parameter. So with uniform ratio parameter you will relax the distribution of this inserted knots. So with these two parameters you can refine the curve segment or NURBS surface automatically. You can also use this set low, medium and high level of detail quick buttons, which set the maximum angle value to a certain value. And you can use this adaptive mode on edges, also on surfaces, so you can pick the row of the edges along the topology of NURBS surfaces and set medium, low, high or custom maximum angle, as well as the other way of the edges. So this is very flexible refinement now. You can choose level of detail on NURBS surfaces into two separate directions, or you can refine everything in the viewport, all NURBS surfaces, all NURBS curves with a single refine button. So you can pick medium, low, high detail, and you can go back to this curve, and this curve can be refined also same way with the refine tool, medium, low, high. You don't need to select particular edge. The whole scene are refined with a new refine tool. The refinement operation is non-destructive, non-precision losing operation. So after more knots are inserted into curve, mathematically it is absolutely precise shape as the previous, previous version of the curve, and it is non-destructive. The reverse operation, automatic reverse operation, reduce operation will be upgraded into next version. It is right now priority number one in next development to do reverse operation on this essential refinement. Next updated tool is the freeze tool or freeze operation. Previous version of freeze is now listed in a legacy in create tab legacy here. You can still use it, but new freeze rewrite it into for mesh TR is in edit tab here, and freeze operation is destructive operation, so we are freezing NURBS curves and NURBS surfaces into polylines and polygons. New version of freeze NURBS tool is using two methods for freezing. I'll show you first on a simple curve. Fixed mode is dividing curve between ISO points to certain amount of divisions. So if you set division to 1, you create polyline just between ISO points of the curve. This is uniform freezing, and adaptive freezing is using adaptive method of refinement. So it is using same routine as the refinement tool, but this tool will immediately freeze that refined curve into points. So that way you can freeze adaptively, and the reason of doing this is if you need more dense freezing on the higher curvature parts of the curve or surface, you are going to use the adaptive mode. So it's same way it works also on NURBS surfaces. So you can freeze a surface by fixed method or adaptive method. So these two methods are now more flexible, so you can use fixed method is of course faster, adaptive is more slower, but you get more dense parts which are more curved. You have more dense mesh on those parts with adaptive method. Next big addition in this version is a road TR tool for creating flat roads from curves and edges of NURBS surfaces. This tool was disabled in previous version. Now it is back and it is redone into mesh TR and works much better. I'll show you a very quick demonstration of this tool on current very simple floor plan. So we have some curves. Before we use Mesh TR tool, it is better to first use join tool, which will automatically remove redundant segments, intersect curves. Then sometimes it's better to also explode all curves into segment and join them back. So after these three operations, you are pretty sure that each segment is a separate curve and all curves are connected in connection points. So we have very clean network of curve segments connected. Next step, if you want to distinguish between main roads, side roads and different kind of roads, it is very useful to switch to color wireframe and to change the color of the different type of roads. So for example, I decide these two roads will be main, so I will change the color, wireframe color to green, to red, sorry. And now we have distinguished two types of roads. Using Road TR tool is very simple. You can activate it, select all all segments, and now with holding Shift key you can change width of the roads, all the roads directly in the viewport. There are many options here, so it is optional. You can, this is very useful, disable showing selected edges, so you can see the clean road. And let's try some options. So here we have road geometry. You can disable road geometry, enable just curves, or enable surfaces. I'll keep it as surfaces. Then you can change edit mode to all segments or specific sketch color. So with this you can set different kind of roads, different width and additional settings. So let's say this way, this will be main road. So white will be main road, red will be side road. Now you can enable road lines. Road lines are generated additional curves as a helpers for further edit. So I will add some road lines also. So let's say for red I will add the 3 lanes. For white I will keep just 1. Oh no, different. Here for white is main, so white will be 4 lines, so 3 divisions, and red will be just 1. And you can also disable road lines with 0. And then I will use also road side lane. So this is the lane between road and end of the road. So let's say I will keep this ½ meter also for white. So this way you have all the necessary components for next modeling of the road. This is pretty quick. This is just a couple of clicks and you have done all the helpers and a full road from any complex network of curves. So road tool job is done, and now I recommend to separate surface of the road to different layers. So now it is clean road surface, and some examples you can use, for example, a new round corner directly on surfaces. So if I select all, select these ends here, and this way you can round corners of the road directly on surfaces. No need to go back and forward between curves and surfaces. For the road lines, you can use the road line tool for creating road lines. So let's say here some example. I will separate also into separate layer. It is always to keep everything in separate layers so you don't get messy results. And maybe I'll join this. Yes, it's better. And now just apply road lines. Very easy and quick, and very flexible with little bit of manual work. Trim, extend, delete tool. You can change road line helper curves into anything you need. Then just apply road line tool, and finally you get, for example, final object like this. So you can see new road tool is very useful and very big time-saving helper. Next very useful new tool in latest version is Topology TR tool. With this tool you can analyze the topology of mesh TR elements. So you can see where are connected or disconnected curves or NURBS surfaces or polygons. And you can also see the indexing of those elements. elements or edges or points. So this is more debugging tool, but it is also used for while modeling. If you forget somewhere is something disconnected and it is clearly not visible directly from seeing the model. Let's try some examples. Here we have two curves, and if you use curve ends mode, you can see where are the ends of these two curves. If I now connect or joined these two, we join to 2 points of these ends are connected into a single, and also the segments are connected into a single curve. Now with Topology TR, curve ends are only on the start and end of this new curve. Disconnected curve ends and connected curve ends, this is visible if you have a connection of more than two curves, like this. Here we have three different curves. If I use Topology TR tool, if you set to curve ends, it will show you where are the ends of each of these curves. If you use show elements, you can see this is curve 0, 1, 2. Okay? And if I set disconnected curve ends, still these ends are disconnected. If I use connected curve ends, then nothing, no point is the connection point here. Now, when I use the join tool, so join tool will connect all these three curves in a single point. So three curves or 3 points from different three curves are joined into a single. Still three different curves, but now this point is only one and is connection point of this all these curves. So now when you use topology, you see still this is curve ends, but these ends in this connection point are not disconnected curve ends because it is now connected curve. If you switch to connected curve ends, it will show you points which is connection point of more than two curves. So with these three options, you can analyze connections, disconnections, connections of huge network of curves, and very quickly analyze what is connected or disconnected. This tool is even more useful when using with surfaces. So when you analyze object like this, very simple object, you can use also open surf edge mode or shared surf edge. So you can see now it is visible where the open edges of this surfaces are and where are the shared edges. And I'll do some example here with explode edge. I will disconnect this edge, which is now invisible. You don't know if it is a connection there or not. And with analyze tool, you can clearly see that here open surf edge is also along this edge which was exploded. So this is very neat and useful tool for analyzing disconnections in surfaces, open edges or shared edges. And finally, some small additions in quad to patches and patches to quads modeling. Quads patch is the tool who can convert quads into a single patch by selecting the grid of quad polygons. And now we have here additional show quads patch option, which will show you directly in viewport the final geometry type. So now it is patch. If you use this tool on existing NURBS patches, then it will show you new quads. So this is much more convenient. And if you want to convert each quad separately, and then for this reason it is very useful new commands. So if you want each quad to be a separate patch, you just use this command, and now this original quad is now NURBS patch, or reverse, you can reverse these patches to quad. This type of modeling will be improved in the next version of LightWave because it has a great potential. You're producing very clean mesh, and this is not just for architecture. In this final chapter of this video, I want to tell you about what you can expect in a next version of LightWave or next versions. This list is again not mandatory. If something will be not finished on time, it will be moved again in next version. But priority is now to finish reducing routines. And not just the linear parts, but also NURBS parts. So the reverse operation of refinement and also reducing of edges of hard linear surfaces. So all in one tool, reducing. This will be again Mesh TR tool, compatible with all Mesh TR elements. Subdivision, curves, edges, surfaces, again complex tool for subdividing NURBS surfaces, NURBS edges, NURBS curves, and all together with topology. Next, welding, very important. Edge to edge, it means if you weld between two edges with different level of detail, the weld will automatically adjust higher level of detail to lower level of detail. This is very needed for patch modeling. Next, projections, curves, surfaces, surfaces to surfaces, all kinds of projection routines. This is very necessary for NURBS booleans, so also very high priority. Finally, some arc-twist to gutters and edge to walls. These two specifics are very needed, so this will be first probably. And many more depends on how development will go. I hope you like the new additions in LightWave toolset, and I'm very looking forward to show you more stuff in the next versions. Thank you for watching this video.